regular class. Okay, so now you can start the test.
Okay, sir.
Okay.
And where should I send it, sir?
Oh, you can send me the PDF after the class. You will make a PDF of the answers. Do not write the questions, only write answer one, answer two, answer. You can either send this on my personal number on or on the group.
Okay.
First complete this and then we will discuss. Okay, all the best.
Sir, I sent the paper on group.
Hello. Am I audible?
Yes, sir.
Okay. Completed the test and have you sent the test to me
Yes,
on
I
the
sent.
group? On the group,
Yes.
yeah. Okay, that is fine. Now we will start our topic. Now we will start our topic that we were doing.
Sir, I'll
So,
join from another device.
what are you saying?
Sir, I'll join from another device only.
You have joined from?
I will join from another device in 1 minute.
Okay, you will join from another device. Okay, you can join. It is fine. सर भाई पानी दे देना यार थोड़ा सा. Okay, Hamza, we will start this. Fine. So we were discussing in the last class. Just wait 1 minute. I'm just asking something. Hmm, okay, no problem. Okay, I'm sorry. Now are you getting my voice? And okay, fine. So we were discussing the this uh, quantitative analysis of dependence of resistance on temperature. Means this time we will calculate the we will calculate the. We have this formula. RT is equal to R naught 1 plus alpha T minus T naught. RT is the resistance at temperature T. R naught is the reference temperature. Alpha is the temperature coefficient. Temperature coefficient of resistance. If no temperature is given, take T naught 0 degree centigrade, and I have given you an example to show you how the resistance will change when you will change the temperature. See here, initially the temperature is 10 degrees centigrade. We have taken the copper, and initially the temperature of that copper is 10 ohm. Resistance of that copper is 10 ohm. And when we increase the temperature by 20 degrees centigrade, means when the temperature of the copper is 30 degree, then resistance increases here 12 ohm, and similar is the case for the gold. So you can see here for different materials like copper and gold is here. The change in the resistance will be different. Change in the resistance will be different. If you are changing the same temperature, then also the resistance change differently because of the alpha. The value of alpha is different for all. For conductor, alpha is positive and have a large value. For semiconductors and insulator, alpha is negative. For alloys, alpha is positive and have a small value. Okay, Hamza, got it? Are you getting my voice? Please tell me. Uh, are you there? Okay, you are here. Yeah, okay, fine. So we will now discuss about the circuit analysis. Circuit analysis, we will discuss circuit analysis. Circuit analysis. So circuit means you will have the combination of resistance wire, and a battery. A circuit is a combination of resistance, or you can say capacitors, connected with wires along with battery. So in the circuit analysis, we will have, first we will discuss the series and parallel combination of resistance. Secondly, we will discuss series and parallel combination of cells. Thirdly, we will discuss series and parallel combination of bulbs. And fourth, we will discuss the Kirchhoff's laws. Kirchhoff's laws. So before this, I want to tell you that earlier in the capacitance, I have told you the division of charge and division of voltage, division of charge and division of voltage. Here in this, I will discuss division of current and division of voltage. So first we will discuss the division of current in circuit. I have to just close it once and after I will open it. So, okay. Division of current. So we have, what is happening here? This is why this is not selecting. Actually, there is some problem in this, I think. So if this is a wire and resistance, this is the resistance in the wire. So in this wire, the current will remain same. If the resistances are like this, means resistances are on the same wire. Resistances are on the same wire. There are no branching. Then current is same. I is the current. If now these are three different wires. Suppose I is the current and this current will divide it. Suppose this is a resistance R1, R2, R3. So this current, now here is a branching. Now this current will divide. Some current will go here. Some current will go here in this direction. Some current will go in this direction. And we can write this I is equal to I1 plus I2 plus I3. So current will divide like this. Now division of voltage. Division of voltage. So voltage divides due to resistance or capacitance or discontinuity in the path. So see, what is the meaning of this? This is the resistance R1, this is resistance R2. Resistance is represented like this. So you can say I current is there, I current is there, and I current is there. But if you want to calculate the potential difference, if you want to calculate the potential difference, why it is not working? If this is a point A, so the potential voltage A here is A. Hamza, hello. Uh, Actually, I have to restart my system again. Okay, can you wait for 5 or 10 minutes more? Okay, please don't leave the meeting. Please don't leave the meeting. I will be back. I'm just restarting my system. Don't leave the meeting. Okay. I'm just leaving. I'm restarting my Okay. So here the voltage is VA. Here the voltage is VA at this point. If you will take the voltage at this point, then here the voltage is VB. Here the voltage is, or not the voltage, the potential is VC. So if you want to find the potential difference, you want to find the potential difference across R1, then this will be VA minus VB. VA minus VB, and this is represented by V1. Potential difference across R2, when you will calculate, R2 is this. So you will write VB minus VC. And this is equal to potential, voltage for V2. So here you can see earlier the potential is VA and some potential is dropped at R1, so the potential becomes VB. And after that, when you are moving from here to here, some potential VB is dropped at R2 and the potential becomes VC. If you have a wire, if you have a wire, this type of wire, if you have a wire like this, then this is point A, B, C, D, E, F, G. So here, if you are moving from at along this wire, then you will see at all the points the potential is same. Means potential at A is equal to potential at B is equal to potential at C, VD, VE, VF, VG. Why the potential is same? Because there is no resistance or the capacitance in the path. There is no resistance or capacitance in the path. If you have a connection like this is one resistance, and this is point A, this is point B, So at this point the potential is A. Here also the potential is A because along the path there is no resistance. Here also the potential is A. Here also the potential is A. But when you will cross this, this potential will be dropped. Here also the potential is A. Here is potential A. This is point B. Here is potential B. Here is potential B, and as there is no resistance, here also the potential is BB. And suppose, sorry, this is R1, resistance R1, this is resistance R2. So if you want to find the V1, V1 is the potential difference across R1. That will be equal to VA minus VB. If you want to find V2, then you will get V again VA minus VB. So the voltage divides due to the resistance in the path. So first is series combination of resistance. So series combination of resistance is like this. This is the positive terminal, this is the negative terminal, and suppose this is point A, and at this point A the potential is A and current is flowing here. Current will be same as there is no branching. There are no branches, so current will remain same here. So current I will remain same. But when you will talk about the potential, then here the potential is VA. Here also the potential is VA. Here also the potential is VA. When you will cross this at this point, if this is point V, then here is the potential VB. When you will cross this point, then here is the potential VC. When you will cross this point, here is the potential VD. If this point is D, then here is potential VD. Here is potential VD. Here also the potential is VD. So from here to here to here to here to here to here, the potential is same. But when you are crossing, the potential is changing. When you are crossing the resistances, the potential is changing. Potential is changing. So if you want to find the resistance, oh sorry, this is battery. And this battery have the voltage V. current is same throughout, but this voltage is divided. Voltage is divided. Here the voltage will be V1. Here the voltage will be V2. Here the voltage will be V3. And V1 is VA minus VB. V2 is VB minus VC. V3 is VC minus VD. So see here, the potential difference across all the resistors is different. But when you will talk about the current is same through all the resistances. If this is R1, this is R2, and this is R3. So this voltage V is divided as V1 plus V2 plus V3. So this is the equation 1. So I am replacing all the resistances with a equivalent resistance. R equivalent, and here is a battery and current I is flowing. So we can write V is equal to I into R equivalent. So this is equation 2. From equation 1 and 2, we have V is equal to V1, V2 plus V3. Put the value of V, I into R equivalent and V1. V1 is equal to I, current is flowing here, I into R1. I into R1 plus I into R2 plus I into R3. I will cancel out. This I cancel out. So you will have R equivalent R1 plus R2 plus R3. So if you have n number of resistance, then R equivalent will be R1 plus R2 plus R3 plus R4 plus Rn. So this is a series combination. Now in the series combination, we will calculate number 1. We will calculate in the series combination total voltage that is V suffix T, and total voltage is V. Second, total current is I, and total current is equal to I is equal to total voltage divided by equivalent resistance. Third point is current through each resistance. Current through each resistance means I1 is the current through resistance 1, I2 and I3 is equal to I. Means current in series is same. Fourth is voltage across each resistance. Voltage across resistance 1 is equal to I1 into R1. I1 is equal to I R1. You can calculate V2, IR2. You can calculate V3, IR3. Next, we can calculate the power dissipated across each resistor. Now see, Hamza, why the power is dissipating across the resistor. Current is flowing through this resistor, and due to this resistance, the power is dissipated because some of the energy is converted into heat. Some of the energy is converted into heat. You can check your laptop this time also. There is some heating in the laptop, and this heating is just the power loss due to the resistance. So the formula of power, P is the power loss, yeah, of course. Power will be lost in the form of heat. You are right. Means you can check your laptop right now. Check your laptop right now. Your laptop is heating. My laptop is heating, and your also maybe heating. So this, we are actually the laptop is running with the help of electric power, and this laptop is heating. Means this electric power is dissipated in the form of heat due to the resistance of the wires. Due to the resistance of the wires. And to calculate the power, we have formula I square R. We will use this formula for power. Power dissipated due to resistance. So if you want to calculate the power dissipated in resistance 1 due to resistance 1, this will be I1 square into R1, and I1 is same as I, so I can write this. P2 is I square R2, P3 is I square R3. Total power, if you want to calculate, total power dissipated in the form of heat, this will be equal to sum of the powers, then I square R1, I square R2, I square R3, and this is the total power we have. I square is common, so here we will have R1 plus R2 plus R3. So total power is given by I square into R equivalent. This is R equivalent. You can note it down. Hamza, noted? Noted this? Noted all or this? Tell me. Note it down. Okay. We will solve one question. Two resistances are connected like this. This is 5 ohm, 10 ohm with a 100-volt battery. We have to calculate the R equivalent. We have to calculate the total current. in the circuit. We have to calculate current through each resistance we have to calculate voltage across each resistance. Fifth, we have to calculate the power dissipated in each resistor. Sixth, we have to calculate the total power dissipated. Total power dissipated. See here, this is the series combination. So current will be like this. Current will be like this, and current is same throughout. Here is the voltage V1, here will be the voltage V2, but current is same. So for the R equivalent, this is the series combination. So R equivalent will be R1 plus R2. R1 is given as 5, R2 is given as 10. This will become 15 ohm. Secondly, we have to find the total current. Total current is I, is given by total voltage divided by R equivalent. Total voltage is given as 100, R equivalent is given as 15. This will become 20 by 3 ampere. 20 by 3 ampere. Third part, current through each resistor. Current through each resistor means I1 is equal to I2 is equal to I3 is equal to I, and this I is 20 by 3 ampere. See here, oh sorry, not I3. Current through I1 is I, sorry, current through 5 ohm is I, current through 10 ohm is I, and this I is given as 20 by 3 ampere. Yeah, okay, you can write in this form also, no problem. Actually, this pen is giving trouble to me. 6.6666 means 6.67 is the answer. The notepad is giving trouble today. So I1 is equal to I2, that will be equal to I, that will be equal to 20 by 3, and you can also write it 6.67. Okay. Answer fourth. We have to find the voltage across each resistor means V1 and V2. V1 is I into 5, V2 is I into 10. V1 is equal to I into R1, that is equal to I is 20 by 3. This will become 100 by 3 ampere. For V2, IR2, I is same, R2 is 10. This will become 200 divided by 3 ampere. And if you want to find the total voltage, not asked in the question, you can find the total voltage also. So total voltage is equal to V1 plus V2. When you will calculate this, you will get 100 volt. We already knew the total voltage. Total voltage is 100 volt. Now they are asking P1, power dissipated in resistance 1. So current is same, I square R1. I is 20 by 3 square into 5. This will become 400 divided by 9 into 5. This will become 2000 divided by 9 watt. P2 is I square R2 20 by 3 square into 10. This will become 400 by 9 into 10. This will become 4000 divided by 9 watt. If you want to calculate the total power, answer number 6. Total power is equal to power P1 plus P2. So this will become 2000 divided by 9 plus 4000 divided by 9. This will become 6000 divided by 9 watt. Or there is one more method to calculate the power, total power. That is, current is same, I square into R equivalent. From here you can also find. I square means 20 by 3 square and R equivalent is 15. This will become 400 by 9 into 15. This will become 6000 by 9 watt. See, from both the formulas we are getting the same answer. And note it down.